So probably you take a look on this slide and wonder, what the fuck is Kubernetes? Why the guy comes to us and talk about infrastructure? Who cares about infrastructure? We are developers. We have the power to change the world and implement everything what somebody imagined. But I have a good news for you guys. Kubernetes is our dream. It's like a black, hello? It doesn't work? Doesn't matter. It is, oh, it's a bug.
We're sorry. It's a firewall.
It's a firewall and they cut this. Okay, so it's the closest thing what you can get as a black box data center as possible. Before discussing Kubernetes and showing you which kind of amazing things it has, and how you can convince your boss or team leader to move your infrastructure to Kubernetes, to save your time, money, and improve your satisfaction, of course. Unfortunately, I do not sell Kubernetes services. This will be in my next slide. So, maybe first about me. I'm a senior software engineer and the head of the team here in Warsaw of a company called SMAC. We are using artificial intelligence to fully automatize accounting. We are doing that quite successful in Germany. Next year probably will be here in Poland. So there's a lot of development in front of us before we can come here. I have very strong system engineering background. I was always during my career trying to escape from two things: networking and infrastructure. And every time I went to the cool startup, I was doing networking and architecture and infrastructure. Of course, also developing the backend services, because that was included in the job, and infrastructure and networking was the extra. And I'm mostly interested in the working software, so I wanted to write here something extremely cool, like distributed systems, but who cares? Working software is the best. And I have a hobby. I'm teaching software engineering on private universities, meetups, and wherever I can. Oh, okay, so the next slide, I create this slide because when you see somebody, you always wonder, dude, why should I listen to you at all? So, I'm moving now atop AI FinTech to microservices and Kubernetes. Before I did it for a top Indonesia mobile e-commerce platform for 1.5 years. And before I had 3.5 years, which I regret till now, with 1,000 of nodes, where I was building a fully automatic OpenStack installation. That was terrible. And I don't like infrastructure. I really don't like it. So let's go to the Kubernetes. So this is like a standard slide. Kubernetes is a Greek word for pilot or helpsman. Its main task is to run containers. So this is the difference between Kubernetes and Mesos. Kubernetes is just for running containers. Kubernetes don't care about other applications. It is based on Google Borg. Google Borg is a famous system that Google developed to fully utilize nodes. Because probably you know that if the node is not running any program, it does not use much less energy than the fully utilized node. So thanks to Google Borg, they were able to get around 98% of CPU utilization and 95% of memory utilization. So they're much more cheaper than Amazon or Azure. And currently, it's becoming a top integration platform for everything. So this is what I told you. Oh, sorry. Come on. Sorry. I don't know what happened. Okay. That was not planned. Oh, perfect. Okay, and the goals for Kubernetes are fully utilize nodes, encourage people to have application and service mindset, enforce loosely coupled architectures, and also include already best practices we can use for building distributed systems. So I see Kubernetes from two perspectives. One perspective is a data center as a black box. So me and you as developer don't need to think about how Kubernetes is installed. Whether it's on the 5 nodes, 10 nodes, 15 nodes, or maybe 1 node. Don't care. And we also don't need to care about things like load balancing and failover, what I'm going to show you. And you have the batteries for your 12-factor apps. I don't know whether somebody knows who is 12-factor apps? Guys, don't do it to me. This is, so if you type 12factorapps.net, you will find 12 rules how to build cloud-native application. Nowadays, we call them cloud-native applications. 6 years ago, Heroku called them applications that are easy to run on production. So let's try data center as a black box. I'm not going to have any demo for you because demo I would need much more time. So I just want to show you capabilities. You can find out the commands, how to do it, easily in the internet. I just want to amaze you that something like that, like Kubernetes exists. So first, what do we need to run our application? We just need our Docker image. Oh God. Okay, my laser pointer is going to be out of. Okay, so what we need? We just need Docker image and 2 configuration files. One is a service, which say what is the name of the service and what is the port you are using to use your service. And deployment says how to install and which Docker image to use to run your application. And what's really nice, you can just say to Google, give me 3 instances of it. And there are 3 instances. And you don't need to care about anything. You just say, I want to have 3 instances. And what I'm going to show you in the moment, Kubernetes is going to load balance all requests to your application, how to say it, that every instance will get the same amount of requests. So, if you are working on AWS, what do you need to do to scale your application? Yeah, so at least load balancer or scalability groups, but it's a lot of fun that you want to get rid of. What is happening if you're scaling down? The same. And Kubernetes has it out of the box. So every third of the requests will get to one of these instances. What is also really nice, Kubernetes has a built-in support for ingress controller. So you can say, every time somebody is calling, let's take a look on the first line, api.smart.io version 1 users, please use service users file1. If somebody called the second version of our API, please transform the request to your different service. Later I will show you that it's a simple XML. And now in your head you can think like, okay, if I need to do it myself in Amazon, okay, route 51, okay, load balance, there's long story together. Here you have it out of the box. So you say that if any request comes of certain port of Kubernetes, it's going to be transformed based on the host that the client is expecting to get. So in this case, on one cluster, I have all my services for my mobile application and web application and my website. Everything in one Kubernetes cluster. So for example, my experience from previous company, we had more than 60 instances on Amazon. And we were able to pack it on 8, maybe 9 instances with Kubernetes. Because before, the startup was growing very fast, so we were saying like, okay, every application has its instance. But suddenly, 50-something, 7,000 euros per month costs, investors are worrying. And then when we made transformation to Kubernetes, it was 8 machines. But unfortunately, nothing is for free. Later I will tell you what is the price we need to pay for it. So this is an example of what we are doing actually. I stole this slide from Traefik website. Traefik is an awesome reverse proxy. And this is exactly what we are doing. On the left-hand side comes the request for different things, and we are routing them to microservices. So maybe we can also do like that. We can display users with one microservice and write to users with different microservices. Why not? We can hide all our complexity behind our ingress controlling. And this is pretty awesome, because if you remember the presentation of our colleague, here the problem that he switched to the next version, and here you can also do like that, that you can keep running the old version. Why not to do it? Just change ingress controlling. I will show you how to do it. and maybe for some time to run the old and new version, and just switch between them. So far so good or boring? I hope not. Okay, so it's another amazing thing. Guys, watch out. I would like to do rolling update. I can just say, Kubernetes, take this Docker image. And what Docker is going to do, remove one version and bring new one. And do the same for others. Amazing, isn't it? I spent like years doing that with Amazon or before with OpenStack. And now I have it for free. So I lost 3.5 years of my life doing things that Kubernetes can do in 3-4 minutes. Regarding load balancing, it's also coming for free. Every service gets, oh God, I have to learn not to click it. Dude, everybody told me test your pointer before. It's a new laptop. Okay, let's take a look what is happening here. Oh God. That always works. Okay, so what we have, what is quite interesting, every of your service will get one unique port on every node. So what you can do, you can build your own load balancer, and you always know that your service is going to replay on certain port. And what is Kubernetes actually doing, if you hit the port, it checks whether the application is locally, not, it forwards it to another instance. And it's doing the load balancing all the time, whether the request comes from outside or inside. So you can see now, when you're building a distributed application, you always hit the performance bottleneck, that you see here that the load balancing is for free. So whether it's internal or external request. And it's pretty awesome because when you are using a cloud provider like Amazon or Google, you can do it by hand. Because you know, I'm going to hit this port, I'm going to have this service, no problem. With a little bit of trickery with networking, you can even, for example, assign the IP address to these ports. Some people are doing that. So it's on networking level, you make the mapping. So I think that's quite cool. Another nice thing is, this is going to make your operation guys happy. Burn one node. And what is going to happen? The cluster is going to shrink, and you will still have 3 instances. Another of one year of my life in Kubernetes. And I was doing that for data centers. So this is especially useful when one of your nodes dies, but it's also amazingly useful when you make upgrades. Kubernetes, you can do live upgrade. So you take a node, you have a command, drain, all your application going to be moved out from the node. You do update is successful, and then you reconnect it. So you don't even need to take your live cluster from operating in your system. Actually, I was doing it many times, and mostly it works. It is also very helpful when one of your Docker application is running Berserk and starting to eat all memory on CPU. Kubernetes is able to detect that and try to migrate applications. So it might be also happen that your application is going to be moved out because some memory-hungry application, maybe doing artificial intelligence or machine learning or just filling memory with something, is going to kick in. So Kubernetes is going to try as much as possible to keep your application running. So another 10, 15 years of people works you have in Kubernetes. And the last nice feature that led us to treat Kubernetes as a black box is federation. What you can say to Kubernetes, I have 3 locations, Poland, Amazon, and Google. Poland, Amazon West is Ireland, this is Singapore, I think. And what Kubernetes is going to do, you are going to have exactly 3 exact copy of your application. So if something happens in Singapore, then your application is going to work in 2 instances. And many people are doing like that. Is a global load balancer in front, and then depending, for example, on geographic location, or if something burns down, you can redirect the request from your customers to the closest data center. Now Google is giving the support to it in its Google Container Engine. I think in the next version, Google Container Engine, load balancing will be global based on the user geolocalization, which is quite awesome. The only one thing that I don't like about this federation is that it's one-to-one. So you are going to have 3 times the same cost. I would prefer to have like, say, some application here, some application here, some application here, but you cannot have everything. Okay, so there's much more. So you see that there is like a data centers. You can treat as a black box. It's giving you replication, it's giving you failover, and giving you load balancing. But there's much more. Here I just mentioned a few things that I'm not going to talk about it because Kubernetes.
It's deprecated.
Huh?
It's deprecated. They're changing the API to deprecate the integration.
Which one? Amazon?
All the integration with the cloud provider.
Oh my God.
Yeah, they're changing as a separate, like binary. You need not a resource inside the Kubernetes.
Oh, it's good to know. I didn't know that about that.
Yeah, I also.
Because in the recent company, I was forced to move to our own data centers, and I had to set it up myself. But regarding with AWS, Google, and so on, what is amazing, if you're in the company that are running on AWS, there is a certain distribution of Kubernetes that is going to automatically pick load balancer and configure them. Also, take volume and attach to your nodes. Also, scale up. For example, you can start with the 4 nodes of your Kubernetes and say Kubernetes scale up to 5. It's going to scale up to 5. Okay, so let's maybe take a look how to start with the Kubernetes, how to use it. So there are 3 concepts. One is the service, which is an interface, which says what is your service name, and also specify what is the port, and also has labels and annotations. This is really amazing because you can describe all the artifacts in Kubernetes by labels and annotation. So you can also build automation on top of it. I will also show how to build monitoring on top of it and alert rules. Deployment is you can think about it as a factory. Deployment says how to instantiate your pods. Pod is the 1 or more Dockers. So you can, per application, you can couple 1 or 2 Dockers. Usually it's 1, but sometimes there are use cases that you can have more. I will show you this. I will come back later. So this is the description of the service. So you have just name. You say you can access this by AT, and here's the selector. Selector is a label which take a look on all your running pods. Doesn't matter how they were created, and match them. So what is amazing here, because it's a selector, it's just a label, so you can have a multiple implementation for your service. So you can imagine that you are, for example, doing the roll up one after another. So you are running version 1, and then you start to introduce the pods of version 2. So you have 3 version 1, then you have 2 version 1, but 1 version 2, then 2 version 2, 1 version 1, and then in the end you can fully replace to the new version. And the next one, so here's an example, a demo. So if you take such a file, you just use the Kubernetes command line. You can create a service deployment. I will show you deployment, how it looks in a second. You log into your Docker, and what you recognize, that your name of your service is injected to all DNS clients of all the Dockers. So all the Dockers can connect to each other by the name. So in this case, we deploy the API status service, which is accessible by port 80, and we can just curl it. Curl API status, and you can just get it. So here's another picture. So here we have service. It can be realized, implemented by many pods, created by many deployments. So usually you use it for blue-green deployments or rolling up by one after another. Here's an example of a deployment. I just want to show you here the one thing is that you have metadata. This is the metadata which is matched by the service. So service just look on the metadata. So it's the perfect loosely coupled systems just based on labels. This service and deployment don't need to know anything about it, about themselves, just about labels. And here is our image. So in my case, I have an API status, a mockup for API status service, which is just running Nginx, which is accessible on the port 80. And here I can say I just need one replica of it. I can say 2, 3, how much we want. And also in Kubernetes, in new version, but I might be mistake, in new version, the next version, it can be also automatic. If Kubernetes detects that the CPU is used too much, it's going to replicate your service. Something like Amazon does for you as well. And the last point, okay, we have service, which is the interface. We have pods that are implementation, and we have deployments, which are factories, which are producing pods as we wish. And we can configure our services with the config maps, or we can also inject directly environment variables in the deployment. So you can imagine that you have this fragment of code just somehow here. So you can just say, this is going to be my environment variables that I'm going to configure my service. And that's all. That's all what you need to do, to be honest, to start with Kubernetes. So you just need deployment, you just need service, and you need a Docker image. And then you can utilize all this nice stuff. This is more about config, I can skip it. So this is what I want to show you, that you can also inject files. So if you are in this old world where you have this long configuration files, you can inject them as a config file and mount them on the Dockers. Automatically they are going to be there. This is one of the ways to provide the configuration to your application. Of course, on the long run, you should have console or Vault or TCD, but for like simpler use cases, probably simple config file is everything what you need. And this was quite nice because we have like a simple semantics, so we have services and deployments, and we just need the image. Now I just want to show you what is the power of metadata and annotations, because this deployment and service files, they are going to be in the Git in your application. So they are in your full control, so you can inform your running system about what the service does. Also, you can introduce or implement an integration with monitoring, alarming, just using labs and annotations. I want to show you how to do, for example, auto wiring or precise discovery. So one of the examples is, I usually do is, I have a Memcache. Memcache provides a Prometheus is a monitoring solution, Prometheus metrics on certain URL. In the old world, I would need to have an IP of Prometheus server and to ship the logs there. But in the new world of the Prometheus, you just use annotations from that. So you can annotate your service and saying, this service supports certain tool. So if you are going to start working with Kubernetes, a lot of your integrations as developers will just look like that. You will just say, I just implemented Prometheus, I don't know whether there's something like that, Nagios endpoint, or any kind of other endpoints. You go to your Git repository, you annotate it, you push it to continuous deployment, and suddenly your metrics are in your monitoring. You don't need to think about it. And most of the extensions for Kubernetes was like that. You just annotate and put the labels. You can also think about your own application where you have components that need to discover themselves. Masters, slaves, or maybe some kind of logging, special logging solution. Or, for example, what you can do security scans. So you can, for example, annotate some services to be, for example, automatically scanned from point of view of security. Okay, and another use case I just want to show you is with case of traefik. Here's this ingress controller where I'm saying that I have api.example.com, and if somebody is connected to the path status, then please use service API status and redirect the traffic to port 80. And I don't want to have a built-in ingress controller. I want to use traefik. The same story. You just annotate things. And this pattern you can also use in your system. You can just annotate your systems to auto-wire. You can also use it for alarming rules, because as we know, current trend is that the developer is responsible for everything. We're responsible for alarming, monitoring, logging, and everything. And what you can actually do, you can just provide the labels which are going to make the monitoring system or alarming system, like alert manager in this case, just use the labels. These are labels. Okay, something is up, has a label that is coming from production, and is a service that is responsible for implementing application. Okay, if something like that happens, please raise the alert, not otherwise. So it quite nicely make this kind of story that you should put everything in your GitHub which is connected to application, because you can use annotations and labels to integrate and auto-wire your tools in production. So you don't need to think about it too much. Another nice example, also from Alert Manager. Here, if I label something severity page, so I should be paged, then my Alert Manager can not, okay, this service is annotated to be severe and very important. Please wake up somebody in the night. And also what is really nice, you did it in production, you did it in your GitHub. You made a decision and you don't need to configure it anywhere else. Okay. So of course there is much more. We have resource quotas, we have events. We can also inform Kubernetes whether our service is ready or not ready. So do you remember this load balancing? And when you bring a service, for example, recommendation engine, which needs 5 minutes to download data, then you can inform Kubernetes, I'm not ready. Please don't transfer me any requests. And then you can fully leverage this load balancer without killing the request from your client. The same liveness probe. If your component is not created to be run on Kubernetes, so it's not stateless and has some kind of complicated and weird logic developed by somebody 10 years ago, you can use liveness probe to inform Kubernetes that I'm dead, kill me. And what Kubernetes is going to do actually is going to restart you. So if you are in this transition period when your component sucks, you can use it to inform Kubernetes, I'm not going to do anything else, just kill me. For example, in my previous company, we had such a recommendation engine. Sometimes it got stuck. When it got stuck, it was running, it was looking like behaving properly, and we just re-implemented a little bit so it kills itself, or at least Kubernetes was able to detect it. That, of course, volume, stateful, and namespaces. Okay, just to sum up, why you should care about Kubernetes is that now infrastructure is in your control. Now, using labels, annotations, you can really see and design how your application is going to run in production. You don't need to bother anybody. You don't need to go to somebody saying he needs to add something in monitoring, because he has better things to do, for sure. And it also gives you amazing possibility to automatize your infrastructure on top, because you can fully describe it. So, as a use cases, you can, for example, generate reports, you can run security scans, and you can also auto-wire your application. So to use it, because then you can fully leverage this named service discovery to wire your application. These files I show you, YAML, are really easy to use, and annotation metadata is also not very difficult to work with. I just want to say you last two things. It's okay? How is it going? Just checking. I don't know, is it interesting? Somebody had experience with Kubernetes before? Okay, good. That's good. And does anybody use Amazon Cloud? Okay, Google Cloud? Mesos? Nomad? HashiCorp Nomad? Okay, somebody is, okay. Okay, change jobs, guys. Go to somebody who is using Kubernetes, okay? Or say your boss. Not me, but to be honest, it's really amazing. You look a little bit puzzled. I don't know, maybe my presentation is boring. Maybe, I don't know. But what is really amazing when you work in the company which has Kubernetes or Mesos is really easy to work. I mean, I'm talking about the stuff because I'm a software developer. I hate infrastructure. If I need to put anywhere IP address, I feel pain in my heart. So for me, it's amazing if I can just say to Kubernetes, just run it. I don't fucking care how, just run it. It runs it. And it's like, nah, performance is fucked. Okay, run three instances. It works. Oh. And I remember from my previous company, I was like, no, dude, it's not a good idea. What are you doing? And after 2 days, like, Wojciech, fuck, that was awesome. I mean, I just deploy application, I just replicate it, and I connect volume, and I add now DNS entry, and everything works. I was yeah, because it should work like that. And what is really nice, these ingress controllers, you can put in your Git repo, so you can fully independently develop. So each of the team doesn't even need to know which kind of DNS names you use for your service. Okay, that was short run about infrastructure. And I hate AWS and Google and Azure and so on. Okay, so last thing which is very important to understand, that this does not come for free. So you have Kubernetes, everything is beautiful, but there's one problem. All topics like monitoring, alerting has to go somewhere. They are not going to disappear. But in the new world, we know that all things should go to the service. So our components have to be much, much smarter. So what you are going to see in the applications which are ready for Kubernetes, Mesos, Nomad, and all these having sense systems, first, metrics. Your application should be metric driven. If you're looking to the logs, you're doing it wrong. You should have metrics. And the metrics should be the first place which are going to inform you what something is going on wrong. So example, at least return how many 200s and how many 500s and how many 400 trees you are returning. Because based on that you can recognize something is going south. This one is controversial. I'm just doing experiments about it. Maybe it's not a bad idea if your component also have annotation which say, dude, you are going to find the alert rules here. I'm supposing that it's going to happen soon, because the more presentation you are seeing from monitoring community, the more things they are putting into the application. So I would not be surprised if one of these monitoring gurus say, dude, you need to provide metrics and alert rules. And then Prometheus service is going to take them and is going to run them for you. So if we go extreme, probably maybe in 5 years we will have also graphs, which are going to say which graphs you should use to monitor them. Who knows? But I'm experimenting now with alert rules. Still, my friends, developers don't want to kill me, so I think this is going fine. Another one which is extremely important, you should have health. Your application should be aware when it's dead. And this should return, of course, 200 when everything is okay, and any other code if something is not okay. But this one you also know for sure from AWS, yes, that you need to give the infrastructure a possibility to react fast, because otherwise you cannot leverage the load balancing. You cannot leverage all this goodness that Kubernetes know when Kubernetes is forwarding requests to that instance. And last one is info. It's also useful. So you can just check what you are really running. Sometimes it's useful. Okay, so now our service is grown up, have self-consciousness, understands its inner self. But let's go further. Now is the time to take even deeper look inside you. So service stand in front of the mirror and ask herself or himself. So first, am I ready to serve requests? Because one, your service is up, but is it ready to serve requests? Often components like recommendation engines, machine learning, data, something, they always have a very long start. So here what you can use this readiness proof. But then you need to ask yourself, because again, what might happen, you spawn your instances, you are happy, you just scale up your recommendation engine, as in my previous company, but your service is dead, because it's still downloading 5 gigabytes of matrix or whatever. Also, what service should be able to do? Kill itself very fast. If detects something goes wrong, just kill yourself. I don't know whether you know, but when you have these satellites, so usually the components are built like a tree, and components regularly restart themselves. Because the developer of the systems knows that they are not perfect, and the easiest way to fix things is to restart yourself. I mean, if you are a service, not a human, I would... Okay. And also another question when you look for other services. What is going on if your database is not up? So this is, for example, like a classic So you seems to be up, but your dependent service is down, and then you are tracked. Or, I mean, screwed, I wanted to say. So again, we look even deeper inside you. So am I really stateless? This is a very important question, because this means whether you need to store something locally on the disk, whether you need caching. In Kubernetes, it is possible to use local disk for caching. To have a really state, yeah, it's much more complicated. It's a discussion for 1 hour, another one, so I'm not going to bring it up. And what is really important is failing fast and starting fast. Because in Kubernetes can migrate your service. So you can imagine you have a very slow service, it's going to be migrated, and it needs 5 minutes to get up. Then you are screwed. Okay, I have, I think, 3 more slides, don't worry. Okay, okay, that's my favorite from my previous company. I hate developers who are developing a master-slave architecture of components because I had to rewrite everything. So I had to change it a little bit to utilize the fact how the Kubernetes works, and of course waiting for other resources. I think it's a 12-factor apps for people who don't know what is it. I think the basic stuff is you configure, for example, your services with environment variables. This is, for example, one of the things which 12-factor apps do. And what is nice about configuring your service by environment variables is that it is easy to run it in different environments because you are not bound to any file. So you can just inject environment variables in your staging, in production, in development, and the service automatically is going to pick it up. That's why, for example, using environment variables for key configurations regarding best practice. Logging. So in case of Kubernetes, this log/stash format is recommended as always. This is another topic, but this also I could make a 1-hour presentation about it, maybe 2. It's what to do with your databases. Currently, I think if you have money, I would put a separate Kubernetes cluster or separate 3 machines. Because databases are more slowing developing stuff. You don't touch them too often, and you always want your application to run on the newest Kubernetes version, because you want to have speed. Databases can sit there even on the Kubernetes version, which is like 5 years old, because you don't care, you don't touch it, but application should be on new clusters. So the easiest way, I would just put them on the separate ones, or just on separate machines. In Kubernetes, you have support for stateful, which somehow take a hand of database and lead it to the nodes, but it's quite complicated, so it's for a separate discussion. Okay, environment. What is really amazing and where Kubernetes shine is how to set up staging, production, canary, and green and blue. Because you can use all this metadata, or you can use also namespaces, which is like namespaces in languages. So the services do not see each other from different namespaces. If you have a lot of money, I would just go always for separate cluster. It is easier, and especially if you have like buggy application, which are going to fill the nodes and then going to affect your production. So I would always go for separate cluster. In my current startup, I'm using namespaces because of some kind of finance, and we also don't have such a heavy application. But if I have money, I'll just go for separate clusters. Okay, so that was all from my side. To sum up, I recommend you to take a look in Kubernetes. I don't know whether my talk was the best advertisement of it, but what I can tell you is, for sure, it's going to make your life better. You don't need to play around with IPs and so on. The only thing which you are going to work with is metadata and annotations. So most of the things, most of the tools are going to be integrated in your application by annotations and metadata. So like SQL versus NoSQL. Freedom, and you don't need to think about it. And regarding the application new world, for sure it's much more harder to develop them. They have to be more self-conscious. All monitoring, all responsibility go back to you guys, developers. You need to think about it. What does it mean when application fail? You need to think and deliver metrics which are going to be useful for people who are running your application in operations. They need to be much faster, much more predictable. Especially this faster and predictable is extremely important, because I have experience from the previous startup, and that was the biggest issue. because we really need to do things step by step, because some components need more time, they were not predictable, sometimes they restarted, sometimes we didn't give enough memory, and so on and so on and so on. And all these lessons that I'm gathering now and in previous startups, I started with my colleague a project which is called Microdevs. You're not going to find there anything today, but probably in 1 or 2 months, where we would like to gather this experience we had and to make it even easier to consume by developers. Especially when we want to take a look into this standard endpoints like metrics, alert rules, health, and so on. But we also want to see how more to use the annotation abilities of Kubernetes. So services can, for example, talk with each other in secure way, discover each other. And we're just looking into this topic, and we're just trying to find the good ideas, how to do it. So, I would like to thank you very much for your time. Yeah, and yeah, let's keep in touch. Of course, I'm hiring. Any questions? Please, at least one, please. Yes.
I wanted to ask about running Kubernetes in development environment. So do you use Minikube, and what's your experience with it? And have you ever encountered any problems?
I can say it. So in the companies that I was working in, I not only introduced Kubernetes, but I had to change the way of thinking of developers. So I told them that development is on their machines, and usually I recommend them Docker Compose, because it was simpler. Because when I was coming to companies, some of people were using a running staging environment, which is not the best practice. So in order for me to force a culture change, I ordered them just to use the easiest way of development. And to give you a more extended, I will set up the development cluster. But in my case now, I have staging, production, and development is on the machine. There was a question. Okay.
Like you mentioned, monitoring.
Uh-huh.
Like for Kubernetes, I do hipster, and for InfluxDB, and it's really hard because it pushes all the labels in the one string with the comma separated, and you need to write crazy regex rules for Influx, for Grafana to select by the labels. Do you solve that? Or?
You mean of Kubernetes? So the question was what I'm doing using for monitoring of Kubernetes or application?
Kubernetes services.
So I'm using Prometheus. Prometheus doesn't have so much issues. It works quite good. Maybe I missed something, but I always was using Prometheus. If you are going to set up your Prometheus agents running on top of Kubernetes, all metrics I was getting was okay, but I never had big issue in Kubernetes, so I'm not probably expert in that.
How Prometheus handles labels? Or does it separate the labels?
The Prometheus has actually a language, and you can do whatever.
Yeah, but
it separates them, so you can select by union of the labels.
Union of the labels. Yeah, because InfluxDB has one string with.
Okay, that's my sucks.
And regex, you do it yourself.
Yeah. So I would go from Prometheus. Prometheus is.
Do you handle workers? How do you handle workers? Like HTTP API for workers or something? You have asynchronous workers in Prometheus.
Yes.
And you publish the metrics.
Okay. So what I'm doing is usually I have a Prometheus inside cluster and I have one outside, and it's just pull it all the time. Pulling all the time.
What scale, in your opinion, it makes sense to use all that stuff on bother about all this?
The Kubernetes, you mean?
From what scale?
So if I would start a new startup, first for sure I would go with the AWS and Docker Compose on the machines, just hard-coded, not thinking about production, just having something working. And then next step would be for me to introduce Kubernetes, because Kubernetes, when it works, it makes life much simpler. And if you have a little bit more budget, you can go for Google. Google have Google Container Engine, and it's just amazing. I mean, this is like, you don't need to care about anything. To be honest, just use Kubernetes, you don't need to. So when I was running Kubernetes for my company, I logged in on the node 2 times in my life. I was one year running Kubernetes hosted, and 2 times I had to log in actually to the node to do something, because everything runs. Yes?
Yeah, how do you run networking in Kubernetes?
So in this, now we use, Flocker, Flow, I don't remember. Tak, yes, Flannel.
Network policy rules?
I don't use that. Currently, I don't use it. So you mean for quality of service, yes?
For security?
No. I hate networking. But probably that would be the next step for me. I'm like developer from my background, so sometimes I don't think about such stuff. That's why it's good.
Me too. I just
Yeah.
What about database migrations?
This is the last question.
Okay.
So you have 2 versions, but are not compatible.
So exactly as our previous colleague said, you need to test it. You need to. The Kubernetes let you to. Sometimes I think about Kubernetes to be like an artist. You can shape your infrastructure as much as you want, but you still need to do your homework and still need to take care of the data migrations. Unfortunately. Ostatnie, tak? Dobrze.
So let's imagine that we have 2 microservices and they're talking to each other. And so is it possible to synchronize this rolling update between them, that one version?
No.
No?
So I think this is also like big differences between this and Mesos. In Mesos, for example, you can have, at least what I understand. In Mesos, you can take a hand of services and lead them. In Kubernetes, you just run them. They have to be prepared to talk with each other on different versions. Okay? Tutaj. Dobra. Dziękuję bardzo. Przyłączenie było. Taka tylko ciekawostka, że 2 lata temu prezentowałem podobny talk, ale o OpenStacku, bo już kiedyś myślałem, że OpenStack będzie takim większym. Szkoda życia. Nie używajcie tego.